Wood plastic composites (WPCS) are composite materials made of wood fiber/wood flour and thermoplastics, includes PE, pages, PVC, etc. Chemical additives seem practically invisible, except mineral fillers and pigments, if added in the composite structure. They provide for integration of polymer and wood flour powder while facilitating optimal processing conditions. In addition to wood fiber and plastic, WPCS can also contain other lignocellulosic and/or inorganic filler materials. WPCS are a subset of a larger category of materials called natural fiber plastic composites (NFPCS), which may contain no cellulose-based fiber fillers such as pulp fibers, peanut hulls, bamboo, straw, digestate, etc. In recent years, people in the flooring industry starts referring to WPC as a type of floor that has a basic structure of top vinyl veneer, plus a rigid extruded core. The core can be made without any wood fiber. WPC is now an established product category within LVT. This type of WPC is different than the WPC decking and is not intended for outdoor usage. Wood plastic composites are still new materials relative to the long history of natural lumber as a building material. The most widespread use of WPCS in North America is in outdoor deck floors, but it is also used for railings, fences, landscaping timbers, cladding and siding, park benches, molding and trim, window and door frames, and indoor furniture. Wood plastic composites were first introduced into the decking market in the early 1990s. Manufacturers claim that wood plastic composite is more environmentally friendly and requires less maintenance than the alternatives of solid wood treated with preservatives or solid wood of rot-resistant species. These materials can be molded with or without simulated wood grain details. Wood plastic composites (WPCS) are produced by thoroughly mixing ground wood particles and heated thermoplastic resin. The most common method of production is to extrude the material into the desired shape, though injection molding is also used. WPCS may be produced from either virgin or recycled thermoplastics including HDPE, LDPE, PVC, pages, ABS, PS, and PLA. Polyethylene-based WPCS are by far the most common. Additives such as colorants, coupling agents, UV stabilizers, blowing agents, foaming agents, and lubricants help tailor the end product to the target area of application. Extruded WPCS are formed into both solid and hollow profiles. A large variety of injection molded parts are also produced, from automotive door panels to cell phone covers. In some manufacturing facilities, the constituents are combined and processed in a pelletizing extruder, which produces pellets of the new material. The pellets are then remelted and formed into the final shape. Other manufacturers complete the finished part in a single step of mixing and extrusion. Due to the addition of organic material, WPCS are usually processed at far lower temperatures than traditional plastics during extrusion and injection molding. WPCS tend to process at temperatures about 50 degrees Fahrenheit, 28 degrees Celsius, lower than the same, unfilled material, for instance. Most will begin to burn at temperatures around 400 degrees Fahrenheit, 204 degrees Celsius. Processing WPCS at too high of temperatures increases the risk of shearing, or burning and discoloration resulting from pushing a material that's too hot through too small of a gate, during injection molding. The ratio of wood to plastic in the composite will ultimately determine the melt flow index (MFI) of the WPC, with larger amounts of wood generally leading to a lower MFI. WPCS do not corrode and are highly resistant to rot, decay, and marine borer attack, though they do absorb water into the wood fibers embedded within the material. They have good workability and can be shaped using conventional woodworking tools. WPCS are often considered a sustainable material because they can be made using recycled plastics and the waste products of the wood industry. Although these materials continue the lifespan of used and discarded materials, They have their own considerable half-life. The polymers and adhesives added make wood plastic composite difficult to recycle again after use. They can however be recycled easily in a new wood plastic composite, much like concrete. One advantage over wood is the ability of the material to be molded to meet almost any desired shape. A WPC member can be bent and fixed to form strong arching curves. Another major selling point of these materials is their lack of need for paint. They are manufactured in a variety of colors, but are widely available in grays and earth tones. Despite up to 70% cellulose content, although 50-50 is more common, the mechanical behavior of WPCS is most similar to neat polymers. Neat polymers are polymerized without added solvents. This means that WPCS have a lower strength and stiffness than wood, and they experience time and temperature-dependent behavior. The wood particles are susceptible to fungal attack, though not as much so as solid wood, and the polymer component is vulnerable to UV degradation. It is possible that the strength and stiffness may be reduced by moisture absorption and freeze-thaw cycling, though testing is still being conducted in this area. Some WPC formulations are also sensitive to staining from a variety of agents.